Assalamualaikum and hi, my name is NAZIRAH binti AMAN. My student ID is 2019208104. My supervisor is Dr. Shariza Hassan. And today I'm gonna present my Viva video, which is ability of different oxidation state of iron-coated bamboo charcoal for the adsorption of heavy metals in wastewater. And this is my thesis presentation outline. First, I'm gonna start with chapter 1, which is introduction. Heavy metal in most wastewater pose substantial risks to the environment and human health. It can lead to abdominal pain, skin rashes, and cancer. Several methods have been used to remove heavy metal from wastewater. These include co-precipitation, adsorption, and coagulation. Adsorption has low cost fabrication and simple operating condition. It also has a broad pH operating range and a great metal binding capability. But the disadvantages include production of solid waste and low selectivity. Recently, a variety of agricultural byproduct derived adsorbent have been employed to remove heavy metal from wastewater, including bamboo, hazelnut shell, and coconut shell hazelnut. Bamboo can be carbonized at a high temperature and without oxygen in a furnace to create carbon straw, which are less expensive than activated carbon. It has been demonstrated that charcoal is a useful and accessible substance. However, unless it is subsequently processed through various modifications, its selectivity for the targeted element remains poor. Charcoal can react with iron to produce complexes, therefore it is required to adjust charcoal to lessen its sensitivity to pH variation to lessen electrostatic interaction of charcoal. Charcoal provides an inexpensive substrate for iron sulfide coating. Bamboo charcoal is a good thermal absorber because it can directly absorb microwave energy by ionic conduction and vaporization. Due to its extreme sensitivity to pH change, bamboo charcoal can create strong electrostatic interaction in an aqueous solution. By establishing a complex between the adsorbent and the adsorbate, it is possible to significantly reduce the adsorbent sensitivity to the pH of the solution. The objective of the study is to test the ability of different oxidation states of iron-coated bamboo charcoal for the removal of heavy metal from wastewater, and to apply the iron-coated bamboo charcoal to purify heavy metals in wastewater. Bamboo is a naturally occurring composite material made of a cellulose fiber embedded in lignin that provide maximum tensile, flexural strength, and rigidity throughout the length of the bamboo. Bamboo has favorable qualities to the microscopically graded structure of its diameter, thickness, and internal length, as well as the microscopically graded architecture of its fiber distribution. The three main chemical components of bamboo are cellulose, hemicellulose, and lignin. They make up around 90% of the entire mass of bamboo. Pigment, tannin, protein, fat, pectin, and ash are the minor constituents. Others include inorganic salt, wax, and resin. In the previous study, locally gargantuan claw bamboo was used as the starting material and pyrolyzed into charcoal. After being chemically altered with nitric acid, copper was then infused into bamboo charcoal. The effectiveness of bamboo charcoal for treating industrial wastewater was measured, and the qualities of bamboo charcoal were examined, and the findings suggested that bamboo biochar had a higher carbon content than raw material despite having a much lower density. Even though bamboo charcoal manufacturing has drawn a lot of attention, the method by which bamboo charcoal is produced and the composition of bamboo charcoal remains unknown. Like other bioenergy feedstock, bamboo offers several desired field properties like low ash content and alkali index. Its heating value is higher than that of the majority of processed straw and agricultural waste, but is lower than of many woody biomass feedstock. Due to the quick growth and increased biomass production, grasses and herbaceous plants are the favored biomass source. When the potential for bioethanol production were examined, it was found that bamboo species has a high sugar content, making up about 62% of the dry matter. Because of its unusually wide surface area and poor volume, bamboo charcoal has a special capacity for adsorption. Using batch mode adsorption research, iron-modified bamboo charcoal was used as a practical adsorbent in the previous study to remove copper from an aqueous solution by adjusting various parameters like pH, contact time, adsorbent doses, initial metal ion concentration, and temperature. To study the physical and chemical properties of adsorbent both before and after adsorbent, equilibrium data were further analyzed using a variety of isotopes including SEM, FTIR, and UV. Bamboo charcoal is excellent for removing toxic substances from wastewater produced by a variety of industrial processes, especially small volume of highly concentrated waste stream like wastewater produced during thermochemical pretreatment of lignocellulosic biomass and wastewater electroplating. Next, we will go to Chapter 3, Methodology. Preparation of bamboo charcoal. The bamboo was obtained from outcut of your item list. The bamboo that has undergoes carbonization process was crushed into powder using mortar and pestle. Treatment with acid. The bamboo was treated with nitric acid to eliminate impurities. 50 grams of charcoal was soaked in nitric acid for 3 hours. The sample were rinsed with deionized water until the pH remained constant. The sample dried. Impregnated with iron. The bamboo charcoal will continue to impregnated with iron after being treated with acid. 5 grams of bamboo charcoal that has been acid treated is combined with 1 molar of iron 2 sulfate and 1 molar of iron 3 sulfate. The solution was stirred up for up to 4 hours at the same speed using magnetic stirrer. The sample were filtered and dried. Sample characterization. The sample was characterized using FTIR, SAM, and UVVs to know about the morphology of the bamboo charcoal that was impregnated with iron. Adsorption capacity of heavy metal ions. Bamboo charcoals that has been impregnated with ferrum 2 and ferrum 3 were added to 250 ml aluminium flask. The flask was filled with 20 ml of copper nitrate solution with a 10 ppm concentration. The mixture was constantly agitated in a 25° Celsius water bath and allowed to soak for 24 hours. This is the result of FTIR. The presence of hydroxide group of cellulose and lignin in bamboo charcoal is shown by the bandwidth near 3410. The bamboo charcoal cellulose and lignin include the C-Singapore or Singapore C functional group, which has been demonstrated by the band strength at 1050. The properties of C-Singapore H bond stretch and band vibration are represented by two small peaks found at 2920 and 1380. While the peak between 1648 and 1760 is indicative of the stretching vibration of aldehyde and ketone, the stretch vibration of C-Singapore O from the carboxyl group contribute to the formation of 1420 peak. There was no discernible difference between bamboo charcoal and the iron-coated bamboo charcoal. This is the same images of bamboo charcoal and iron-coated bamboo charcoal at 500 magnification. Large pore may be seen in the same picture of bamboo carbon. The same micrography revealed that bamboo charcoal exterior surface contains pores of various sizes and shapes. The picture shows the surface of iron-coated bamboo charcoal is substantially coarser than the small surface of bamboo charcoal due to the deposition of iron sulfide particles. The micrograph of iron-coated bamboo charcoal simultaneously demonstrates a reduction in the amount of pore space and surface area accessible for absorption as a result of iron sulfate coating. The adsorption properties of bamboo charcoal solution at different concentrations are shown at a wavelength between 400 and 550 nanometer. This figure shows as the concentration increased, the adsorption also increased. It is expected that the adsorption property of bamboo charcoal is improved when impregnated with metal. The absorbent peaks were recorded at wavelength of 400 and 550 nanometer. The adsorption of iron 3 coated bamboo charcoal showed the highest compared to the bamboo charcoal and iron 2 coated bamboo charcoal, where the adsorption graph of bamboo charcoal shows no significant difference compared to the others. The shoulder peaks of the graph at all durations were slightly shifted to the right. The highest peak recorded at iron 3 coated bamboo charcoal at wavelength 484 with an absorbance of 1.968. According to the finding of this study, iron 3 coated bamboo charcoal performed better at removing copper than bamboo charcoal and iron 2 coated bamboo charcoal. Additionally, the iron 3 coated bamboo charcoal has a higher surface area, enhancing its ability for absorption. With increasing solution pH, temperature, and oxidation state, the absorption of copper by the iron 3 coated bamboo charcoal reduced, indicating that the absorption process was spontaneous and exothermic. Bamboo charcoal with iron 3 coating may be used as a possible adsorbent to remove heavy metal from wastewater. Bamboo charcoal that was produced by pyrolysis or carbonization process has extraordinary properties such as high conductivity, large surface area, and absorbent property. However, these properties can be further improved by an activation process that can be done thermally or chemically. Instead of UV visible spectroscopy, we can use atomic absorbent spectroscopy to analyze the sample. It is because AAS is more accurate than UVVs. AAS analyzes metal, while UVV spectroscopy analyzes colored compound and organic compound. UVV is only able to provide an appropriate wavelength compared to AAS, which can provide a specific wavelength for its scattered length. That's all from me. Thank you.